Turbo now?
Turbo Puffer, it's 3 years in May since I wrote the first code.
Okay, so we're a couple of years ahead. You've got more time to lose the hairline.
All right, let me share this now on X. 1 second.
Oh yeah, I think mine's done.
We gotta. Let me just see if mine actually did it. I don't think so. No. Okay, I gotta just hit the share button then.
You're gonna do your own stream. Post this.
Live with Sam Lambert. It's just Sam Lambert is your right?
Yeah,
Sam.
I paid for that.
How much did you pay for that?
No, I don't know. Actually, not much money. I don't think. I can't remember actually. They were really good. The Twitter team, X team, were really good to work with. Did
you do it after they made like a proper marketplace for it, right?
Yeah, I got early access. I was given early access to that, and then I found it. But like I've been trying to get it for years because the person who had the real name wasn't even called Sam and hadn't posted since 2013. So I was like, I want that name, and it was very confusing.
How did they handle that at GitHub? Because there's a bit of a black market too, right there for handles.
Yeah, there is. I don't know what we do officially. Actually, there would have been some official policy for like turning that stuff over. People would try and buy them. That was against terms of service, though, and people would offer. Oh, the weird. Okay, I'll tell you a story. So we were at GitHub. A traditional thing to do was people would like in the early days would go and join the support team for a week. Which is a good thing. Like you just
like this was onboarding, like the onboarding week. They would be on support. No, okay.
No, and I didn't quite do that a whole week, but actually at one summit, like we'd have these company summits where the whole company got together. The support team, who were amazing, by the way, the early days support team at GitHub were just outstanding. And in fact, the first support hire I made at Planet Scale was one of those guys. Shout out John Greet, because just everything he embodied about support was just like so good. And that was like the early culture of the team. Anyway, so at a company summit, I was like sitting with them and fielding support requests because it's like so busy, you know. And someone wrote in wanting to change the creation date of their GitHub account. Like you can have like when you signed up. And I replied like asking why. And they wanted like April 1st, I think was the date. And they were asking why. And I asked why. And they said, you know, it's a more professional date to have is April 1st. And
is April 1st not the least professional date?
Oh, actually, good point. I don't know, but they just wanted a more professional date to have signed up on because it was some like 17th of some month or whatever. And we said no, obviously. And then I put a calendar invite for myself to check, and they did delete their account and re-sign up on the day they wanted to get a more professional date. That was a really fun thing to watch, and the kind of support requests we would get were nuts. People would sometimes write in as well.
I think that's PMF when people are like grooming their profiles like that.
What do you mean? Oh yes, for sure. That is a PMF.
If you're caring about like creation date, you're caring about like your avatar. I mean, now GitHub also allows you to do. I mean, I remember that like dragging the repos around to which ones you wanted to display, right? And you just like you didn't have a ton of real estate. The contribution graph has also been that. Yeah, there's a lot of that. How do you you said earlier that the early stage GitHub team was support team was phenomenal. How was that team assembled? What were the backgrounds on the people that joined the customer support team and the culture?
So this was long before me. The first hire was a guy called TechHub. Actually, you may know that name from the World of Warcraft. Do you remember TechHub's bar mods and all the old WoW mods?
Yeah, I used all those WoW mods, and so I'm like,
so as soon as I joined the company, I was like, that's an interesting name. And yeah, no, like it was him. And I'm looking, wow, the webpage is still up. Tab R0, my God, wow.
What is he doing now?
Is
he still creating WoW mods?
No, I don't think so. I doubt it. Wow, yeah, look, it's got they're still up on GitHub. Crazy.
By the way, for everyone who's joining in, Sam and I are just talking yapping about whatever, and then we'll kick it off in just a few minutes.
Yeah, we're just waiting for people to join. Well, we say we're doing that, but I forgot that's what we were doing already. So
yeah, this might have just been it.
It's the ADHD just ripping around. Anyway, so like he was hanging out in the GitHub IRC apparently, and this was like way long years before I joined. But
GitHub an IRC channel, like an official IRC channel. That's awesome. That's so good.
And he was hanging out there, just helping people, being friendly. And Chris apparently reached out to him and just hired him, which I thought was a very good organic way. And that's actually thematic. We just hired a community engineer who was an engineer at a company that uses PlanScale, and he was the guy that was in our IRC all the time, helping, not IRC, Discord, the modern IRC, helping out all the time. It was good. Yeah, I mean, it's funny how those things happen. That's actually a good way of getting a job. If people are looking for jobs, just be part of the community, like shore up open source libraries related to the company, things like that. It's always like really helpful.
Yeah, absolutely. So good, and people will take notice.
Oh, the boss.
There's Ben.
Here he is, boss man.
Hey, I'm not the boss, but I am here.
Stream quality mogging us as well with the setup and the mic and everything.
Somebody left a chat. Sam's background has the essence of Ben's balls. I probably shouldn't say that on stream.
The essence of the balls.
I like the theming. Yeah,
that is a PlanScale poster for one of our values.
It took me a second to understand that these we're talking about the performance balls here. Of course.
Yes. Yeah. Which were ultimately inspired by you, Simon.
Yeah.
Like, I think you're really the originator of them. So you all have Simon.
I've never done the balls. The balls were like genius, right? Like I wish I would have had the insight.
But you did the napkin math, right? That's you.
Just adapt. But you didn't even know about that. You came.
No, I did. I did.
Yeah. I thought you independently discovered that much later. Oh, okay.
No, that was like I discovered that, and it was like a couple weeks later that I did the latency balls. So.
What I really want is, and maybe someone's listening who wants to do this, is probably like my basically between Shopify and PlanScale, I spend a lot of time on the Napkin Math project. For those of you who are not aware, if you just Google Napkin Math GitHub, you'll find this repository that I used to maintain. I mean, I still kind of maintain it, of what's the latency to object storage? How much bandwidth can you drive from object storage? What can you drive from NVMe SSD? All these different things. And it's like, it was kind of just sitting with these numbers that I came to all the bits and pieces that led to Turbo Puffer. But if someone is watching that likes that work, we would love to sponsor someone to take it to the next level. And I think PlanScale will probably come in on it, right? We've talked about this before, right, Sam? You'd split the bill with me?
Oh, fine. Yeah, I'm fine
because
with that.
What I want is like, I want latency. Like I want like a histogram of the latencies, right? Because with object storage, the P99 is quite far from the P50. On an NVMe SSD, not so much unless you're close to saturation, blah, blah, blah. There's just a lot more numbers that I would like to have. And I just think it's super important. I think profiling is like great to get a few percentage, but if you really want to do the big performance improvements, you need to like sit down and just like construct a little model, multiply some numbers together, and see how far it is from how the system is performing. Because otherwise, you're not, like, if you're just reasoning against yourself, it's like running a race against yourself. You're not looking at what the actual underlying machine is fundamentally capable of.
Yeah, it'd be cool to actually build like a continuous benchmark for that. Like there's a website, I don't know if it's still hosted, but somebody set up some infrastructure where they pinged every region in AWS from every other region in AWS, like once a day or once an hour, with like continually updated latencies. And this would be cool to like have a similar kind of thing like that.
My dream would be Napkin Math running like daily, kind of like the Lucene benchmarks, and then on pretty much all of the modern machine types. And just like that to me would be the holy grail, with histograms of all of the different latency distributions and all of that. And then an active community around it where everyone's trying to, disassembling the code and trying to make sure that it's performing optimally and tuning the kernel.
Why, by the way, we all get, like, when you use these services like Amazon services or whatever, you end up getting to like really learn about them, and like from various support requests and things you learn out on the internet and talking to other people that use these services at scale. We've certainly figured this out with EBS, and we've figured it out by having like access to a lot of customer accounts as well that can see the same EBS infrastructure and then like correlate issues. What is the reason for the big P50, P99 like variance on S3? Do you know?
I mean, I think it's just that you have a probably pretty high utilization system. You have a lot of HDDs. HDDs have large latencies. It's a big distributed system that has high latencies. Even to access a single object, right? I'm assuming that there's some parity encoding where you're often getting from multiple machines. So it's just a massive fan out. It's just a big distributed system with HDDs that have large random read latency in the first place. So it's always made pretty good sense to me.
Yeah, I mean, it does make sense. Do you want to tell people about the actual architecture of S3 and how incredible it is, how it takes 6 weeks to do a deployment? Like, it is got to be one of the greatest pieces of infrastructure around. It is just a phenomenal piece of technology, like unbelievably cool.
I don't like, you know, at a high level, the way that I think about it is that request comes in, it hits some proxy layer. That proxy layer acts as some metadata layer that tells you about where the blocks are for the file or the range or whatever that you're trying to access, and then you just go out to a large distributed fleet. As far as I understand, you know, they do a bunch of parity encoding, so the block or parts of the block might be present on multiple nodes, so they'll do a couple requests to satisfy it. What the actual underlying block size is, I'm not completely sure. I'm assuming it's like a few megs, maybe 1 to 4 megs based on the latencies that I've seen. And then it goes out. I think one notable takeaway there is that you hit sort of the metadata layer before you hit the storage layer. And there's lots of requests that you can make to S3 that only need to hit the metadata layer, which has a much tighter latency span than the storage layer. And so on S3, if you just access the metadata layer, you might get a P50 of around 8 milliseconds. On GCS, it's around 14 to 18, depending on the region. And that's just to access the metadata. So if you're doing compare and swap, or you're getting a very, like you're just getting metadata, or you're just checking if an object's e-tag is the same, basically just, is it a cache hit or not? Is my local cache consistent? You can do that with a much lower latency, like 8 to 15 milliseconds, which is part of why TurboPuffer can be designed to use S3 as the full consistency layer, just because those requests only take 8 to 15 milliseconds, which is pretty good for search. And also because you can basically assume that the state that you have in cache is valid and continue to do all the computation, and then as in concurrently check whether it's valid. If it's not valid, then you can restart with whatever is consistent. But like, you know, with 5 nines reliability, whatever you have locally is probably right, and you only restart if you're not consistent. And you could do that in 8 milliseconds on S3 and 15 to 18 milliseconds on Google Cloud Storage. I think Azure is actually even lower. I think Azure might be 4 to 5 milliseconds, yeah, for the metadata layer, which is surprising.
Yeah.
And
I nearly said something mean then, but I was very nice. I was very nice. I kept it in. I really kept it in.
I'm really proud of you.
By the way,
your face said it all, though.
Yeah, well, you know my face well enough to probably have guessed exactly what I was going to say. Yeah, wild actually. So what do you do? So this is for your audience. What do you do to mitigate? Like that to me is a very slow time. Like OLTP land, that is like a crazy P50, obviously. I mean, not for some, but
for metadata, you mean?
Yeah. So what are you doing? You're obviously storing caching data locally, right? You're actually running on the same NVMe machines that we do. Like, how does that architecture look? And how is it okay, put it a different way of saying, like, I think this architecture is mostly a bug in most OLTP systems, but it's a feature in TurboPuffer. And that was your main insight coming into the industry, right? Like people were building vector search or just general search on like more OLTP architectures, and it was the wrong architecture. You chose the right architecture. So why is it a feature for you and a bug for us?
So it's a feature for us because building a reliable storage engine where you're not losing data takes, you know, it's like common database wisdom that it takes 5 to 10 years to do that. By fully piggybacking on object storage, we don't really have to do that, right? They've solved the durability problems for us. Yeah. If you are building something like, if you're building a relational system, it just takes a long time to iron all of that out, and the replication, like all the conditions on the compute, because the compute nodes are just very they can act in all kinds of funny ways at 3 a.m. So for us, part of the reason is that we've just built production systems for so long that we only wanted to be on call for something where literally every single compute node can die and we don't lose any data, and it doesn't matter when they die. That was a hardcore design constraint that we took when Justine and I were designing TurboPuffer and started using it in production. But the other design decision that we made is that we wanted consistent queries. Most search systems do not have consistent queries. If you insert I think with default configuration in something like Elasticsearch, at least these were the defaults when I used it a lot, and I think they probably still are. If you insert a document, it is not immediately visible, right? You insert a new document and you search for it, then it's not immediately visible. And the reason for that is that they merge the documents into the index later. And so it's an eventually consistent database. And TurboPuffer just made the decision very early on that we wanted to be strongly consistent. Yeah. It was mostly just from, like, that's the least surprising behavior, which is generally what I try to design for when designing APIs. But it means that since the consensus layer is object storage, you have to go to object storage to know what the latest objects are, which takes 8 to 15 milliseconds, well, 4 to 15 milliseconds, depending on the object storage, right? 4 to 5 on Azure, 8 milliseconds on S3.
Why is so slow, by the way? Why do you think GCP is much slower?
It's, well, you'll like this. It's the Spanner front end, right? That's doing the 18 milliseconds. And I think it's doing it across probably 3 ACs. And that's why I think it's so variable between regions. So it's just for whatever reason, that's the lower bound. I'm sure they're working on improving it, but that's the lower bound that they have. Now in TurboPuffer, you can turn this off, right? We can just serve it from cache, and now you're getting query results in like a millisecond. But yeah, for old CP, 15 milliseconds is way too long. If you have a Rails app where you're just single threaded, making requests back and forth to the database, you can't do a lower floor on a write or a read that's like even 5 milliseconds. Like if you did that to GitHub or Shopify or Airbnb or whatever the big Rails apps are, and you lower the floor latency to 5 milliseconds, or like had it at 5 milliseconds instead of like 500 microseconds, it would just completely tank the app. Yep. So you can't get consistency that way. Now you could use like a Paxos thing or whatever in front of object storage. I'm not ruling out we'll never do that. But for a new database, I think this is a really, really good trade-off.
Okay, so this ties into a question I wanted to ask to kick us off 20 minutes in now, but hey, here we are. So both PlanetScale and TurboPuffer are building really high performance database products, but also with great reliability, right? These are tier 0 pieces of infrastructure for thousands of companies. And I guess, Simon, you kind of just answered that, but like, what's the way that you both think about that balance between like ultra high performance, ultra reliability, and why that's so important for all the companies that rely on both of these technologies?
You should start, Sam.
You know, databases are just so important for every product that if they're not there, the product just ceases to function. You can fail, and they're just such monolithic blocks of state, right? Like until you're sharded, but even then, right? You pretty much, it's up or it's down, right? Like even if you can just read, even if writes go away and you can just read, eventually that becomes like a bad thing. Like it's actually funny, most people's products have different kind of trade-offs here, but you know, if you can't write, people can't change permissions or, you know, remove employee, you know, like you just, unless your database is up in one go, your product is down, right? And I've said this before a number of times that the database is such a critical part of your product. If you go to any product, like you go on twitter.com right now, okay, I'm looking at twitter.com right now, you can see, you can't share screen with this thing, can you? That'd be really cool if you could, never mind. But
you can if you want, but
oh, you can. How do you do that?
At the bottom, there's a share screen. So
I don't see one. Oh yeah.
Yeah, a little monitor with a plus icon.
Can you share specific windows?
I think so. Yeah.
Okay, let me see. Oh yeah, wow.
We are live on the entire internet though, so you know,
that's
share
fine.
With caution.
I don't mind. Here we are. Can you see this?
Let's bring it on. No, there we
go.
Look
at that.
There we go.
Look, by the way, just 3 accounts, just to make that very clear. Okay.
That's why it took a long time for you to
Yeah,
log
that's
out.
what it was. Yeah, to log out
Yeah.
of the average CEO or whatever. But look, Holly, I got back in. Anyway, every single thing on this web page is coming from a database, right? Like when I get my session, it says who I am. It allows you to go to object storage to load my profile picture. Maybe the mapping is even stored in the database. Every single one of these, like my timeline, my notifications, what's happening, every single part of this web page is coming out of a database. And it's personal to me. It's my follow account, my follower stream. Without a database up behind every web product, it's essentially just an empty template, and is useless. And so if you don't have your database up, you just don't have a functioning product. And that is extremely important to people. It's made significantly worse, though, by durability is another one, right? A trade-off that everyone has. And you have to do it while being available and safe with people's data. If you lose data, it's even crazier, right? Like you lose someone's Strava score or whatever. Terrible. Awesome. Sorry, what were you gonna say, Simon?
I was just gonna say that I think also when you look at a website like X or the ones that we know, all these little pieces of information are coming from a database. Every single page takes hundreds and hundreds of queries. And this is why the P99 on an OLTP database is absolutely paramount, right?
Yes.
For search, I can have at least while TurboPuffer is very focused on mostly search, I can have a P99 of say 50 milliseconds, and it's not the end of the world. Like it's actually like that's completely great in search land. If you have a P99 of 50 milliseconds, that means that like tens of queries on a page load potentially are that slow, which depending on how the app is rendered and how the waterfall and the dependencies happen, will slow down everything. So you just can't, you can't afford that. And that's why you have such a fundamentally different set of trade-offs to make. It's a lot more expensive per gigabyte. That's the biggest trade-off. But in turn, you get a P99 that would be very difficult for something that's like very reliant on disaggregated storage to have.
Yeah, you need so much of that data hot. And even like hot for us, right, is still just on disk. It's not in the buffer. That's an even more like that's a whole other layer of caching. You get, and you have an additional layer behind you, which obviously would make things good. And like people will talk about these like mixed mode OLTP systems. People talk to us about potentially doing that. Like it'd be great if you could back certain tables off to object store, but then people are never going to be disciplined with the access patterns, and you're going to join on a table that's going off disk or off the machine or whatever and just drag the whole thing down. And it's those errant performance, like when you see that spike in P99 as well, you tend to like stall web workers. Like there's all these just like cascading things that come from like a slow database. So much worse, so much worse. So why does search get away with being slower?
I just wanted to make one more point on database before we move on. I think one way you can think about a lot of databases is like there's sort of like three ways to store, like three places, at least in a modern database, that you store data today. There's object storage, there's the local, hopefully SSD, like it's just like you should be trending towards that, or DRAM, right? And for something like OLTP, you want 100% or at least like 95% on NVMe, maybe 5%. There are some tables that have the latency of being on something different, but like you want like 95% on NVMe, and then some large percentage in DRAM. And you're still very addicted to that, right? Like if you're failing over a MySQL, you can actually, how do you deal with that? Because I know if I fail over to a replica, I know I'm going to have, like, if you do that naively, you might have 5 minutes of downtime because you're waiting for the cache, like the DRAM cache, to be perfect. Do you have anything in PlanetScale that mirrors like the read queries to get the cache just right?
We have pre-warming for the test, and we're building it for Postgres right now.
You have that already?
Yes, you need that for certain systems.
Do you do that? Like if I fail over right now in PlanetScale, is it pre-warmed?
Really? If it's a planned failover, it will have already warmed the machines below it.
How long?
How long for that to happen?
Yeah. How long does it pre-warm?
I don't actually know. I'd have to.
Like, is it 5 minutes, 10 minutes, an hour?
I think it's until we see like basically the queries we're sending it becoming a lot quicker.
Okay, so it's dynamic.
We used to do, at GitHub, we had the craziest way of pre-warming. It was a shell script that just used to TCP dump and send it to just grab any Slack queries it could. That works really well. But replication, by the way, replication does a decent amount of warming anyway, because it will pull those pages off of disk to modify them and make them dirty anyway. So you get a decent amount of pre-warming. And then if people are using replicas just to read, that's obviously going to be the best way to do it if you have it.
Yeah.
It's like a hard problem. It is a difficult problem, especially if you're running these massive boxes with these huge amounts of memory. You need to get that into. Also, though, another thing that MySQL's had maybe since your day is buffer pool saving. I don't know if you know that. You can save the buffer pool to disk.
No, I didn't know that. And so then when you restore, you just restore the buffer pools directly.
Because you remember how
does it actually snapshot the actual buffer pools, or just like pointers to what pages it needs to be loaded in?
It's just the LRU or whatever the list is that it maintains for what's
Postgres doesn't have this.
No.
So you just have to pre-warm it. But this is like, I didn't even know that Planetscale did that. You gotta tell people that.
Do you think that nuance goes across? Do you think the importance of that goes across? I think you appreciate it, but do you think that gets out there?
I think it's just that most people will assume that a failover is just you point an IP somewhere different. You do pausing, you do pre-warming, you make sure that it's caught up, you do the right, like there are so many other parts of it that people do not appreciate. I think you could write, I just think you could simplify, even maybe like in the limit, in the UI, it would be incredible if this was showed, right? Like if you just like, when you failed over, it just to educate. I love UIs that educate people on the complexities that people deal with behind the scenes, but I didn't know it. For people's reference, right? If you do a disaster recovery on a big enough site, right, and you've done any amount of optimization of your database, then you can't just fail over to your replica and expect that the site is up, because you fail over and the caches are not right? The wrong things are going to be in DRAM from NVMe to hit that steady state where your performance is correct. If you failed over, I guarantee that this is still the case. If you fail over a Shopify shard from a writer to a reader, it will be very slow on a busy shard for probably a few minutes. Maybe it's in the seconds, like probably a few minutes, until the caches hit the right equilibrium that everything's good again. And so in order the only way to do that, which is what everyone does and what Planetscale just handles automatically, but that everyone else does ad hoc, is that you have to basically mirror the read queries for a time so the caches read the right equilibrium. And these cache sizes are very, you could just go ahead and just like, I have 2 terabytes of disk space per shard. I'm going to have a 2 terabyte DRAM cache, and then you probably wouldn't have as much of an issue. But you're trying to optimize that. You want that DRAM cache to be as small as possible.
Well, that's the other thing, by the way, as well. The good thing about sharding is you can run much more smaller nodes. That's significantly better as well. Like vertically scaling up to like 60 terabytes on a single node is meant. Although we did that at GitHub. Obviously, everyone does that before they do sharding, but it was crazy. Talk to me about caching. What did Shopify do for caching?
There's basically two things that was done for caching, maybe 3. One is just the cache objects in Memcache. So basically going directly to Memcache before going to the writer. I think.
Could you live without that Memcache tier? By the way, sorry to cut you off. Most sites can't, right? Like Facebook would be dead without the.
No, I don't think so. I don't think so. No, it would, if that turned off, there's problems. That tier though is so stupid reliable that it just didn't really happen, right? But again, it was one of these things that would have to be pre-warmed. Later on, we designed, when Justine, my co-founder, and I rewrote the Shopify storefront, we went much more all in on using read replicas and using the tricks, right, of cache coherency with the read replicas is very, very tricky because you deal with replication lag and you need to make sure you're not writing back values and things like that. But if you've been doing it for a while, you know the edge cases and you know how to put the patterns in the application to make sure you're not writing back stale data back into the database and tainting those objects and stuff. And in general, I like to use read replicas instead of having an external cache. I think it is easier in the limit to reason about because you end up you know, you just end up with bugs where someone gets something out of memcache, don't realize it. It's not like 99 point, like it doesn't have like 5 nines of cache coherency. And so you get that object back and someone might then write it back into the database. And that's super dangerous. And you have to put a lot of protections in place so that you don't do that incorrectly. So I'm not a huge fan of that. I like using the read replicas a lot more. I think it's a little bit, it's like harder and easier to reason about at the same time. And I think it takes more ops to do it correctly. But overall, it's what I prefer.
Did you see how casually he mentioned rewriting Shopify's storefront? As if that was just a thing you did for fun. That's a whole other story we should get out of you as well. Why did you rewrite the storefront? Was it just for scalability? Like, what was the reason?
The reason was it just needed a rethink of the way that everything was done. We just wrote it in pure Ruby, and we just like took all of the different applications and like all the different components. The way that Shopify storefront works, right? It's like you have this thing, this templating language called Liquid. And Liquid is basically like, hey, I want the cart and I want to show this part of the cart, right? So just like dynamic thing. I think Toby probably wrote this.
User facing. Yeah. So
this is
like
I've
never set up a Shopify storefront. I've lost insane amounts of money through them, but through buying just constant crap while I'm bored, and every website seems to be a Shopify site. But no, so this is like a templating language for users to build their storefront.
Yeah, exactly. And so, I mean, at this point, there's a lot of UI on top of it, and there's different ways of doing your storefronts, but that's the underlying engine, right? Like, get me the cart, get me all of this. So we just needed to fundamentally rethink it. Like, we did all these like interesting patterns. You'll like this. So Liquid is just dynamically rendered, right? And so it's just like kind of Ruby rendering where you're like, I want the cart, and then I want these particular things from the cart. And then based on that, I want to show this other thing. So it's just like, you have this waterfall of dependencies, and Liquid is not written in a way where we can just like, okay, render, here are all the objects, batch it together, and then do the queries. Like it's not designed that way. So we had to find another way. And so one of the tricks we pulled was basically, of course, you know, you go through the entire page and you cache it and you put it in memcache. And then if you know that the cache key for that page is still valid, then you just serve directly out of memcache. But we were really trying to optimize for cache misses as much as possible.
Yeah.
One of the tricks we employed was, okay, so we can't just like pre-render the AST of the Liquid. Like, we have to do it as we go.
Right.
But the queries that we're doing are probably the same as last time that we rendered this. So we had another cache key where we're basically like, okay, at the beginning of the request, let's start like loading in and firing off the same SQL queries that we did last time. So basically, like, imagine like this is the cache key, and the cache key just had like a list of SQL queries. And at the beginning, we would just fire all of those off. And then as we render, we can basically go in and see, oh, like resolve those futures and see if it's already been resolved, and then not like kind of avoiding this like big waterfall. It's like very, very pragmatic. So we were just doing a lot of things to just simplify the whole thing. It was running on more than 95% of traffic, like about a year and a half later after we started the rewrite. This is in like probably 2019. And it was just, Toby wrote the initial prototype, and then Justine and I took it over, built the team around it. And this is still powering most of Shopify today. It runs in like multiple regions. Like, we had to redesign for that. It was extracted out of the main Rails app. I was initially very skeptical of doing a grand rewrite, but it worked out. And I think that the most clever thing we did was that in front of the old storefront and the new storefront, we had Nginx. And Justine and I came up with a solution of like, we're going to build this like a JIT, because you're basically like rewriting the whole thing. It has to be bug compatible. It's like a nightmare with these. There's like millions of templates that are all different, and people rely on bugs and whatever, and it all has to be the same. So we put Nginx in front. And when a request would come in with some probability of whatever we had capacity for, we would send it to both. Then it would come back to Nginx, and we would look at the HTML. And if the HTML was the same, we would start sending everything to the new render. That way, we basically had a graph of like the percentage of traffic that was rendered with storefront render. And then we just like kept track of all of the, like, trying to categorize the different edge cases, right? And trying to and get them out. They were like, okay, well, we made this deliberately different in the HTML. And so we called this the JIT, like the just-in-time like render. And that number just like kept going up, right? And we would have a really good idea of what we needed to get it even harder, even higher. And that was extremely motivating for the team because you just had like people, and you sharded the people by, well, this is your area. And I think that was a really, really motivating way to do a rewrite because we had production traffic running on this, like just a few months into the rewrite, focusing on the biggest site that were doing the most traffic for Shopify and cutting down the rendering costs dramatically. I can't imagine doing a rewrite any other way.
No, I do love those big projects though, especially when you're running there's so many I've seen, like the rewrite of the Git stack, which is just like this long tail of like going through all of these problems until you just run down this massive, really long project. Like it just takes way longer than anyone expects, but is incredibly motivating. The day you get done with 100, it's just like 100%, and just you flip. And the most fun, I don't know about you, but the biggest, most rewarding part of those projects is turning the old infrastructure off. Knowing it's gone forever is so nice. I got one question for you, then I want to dig into something you just said. A quick one though. What's your chosen method for avoiding reading when you're trying to read your own write but you're using read replicas, right? Like this is a thing that everyone stalls on. They're used to reading their own writes. What do you do to like avoid that breaking? What's your chosen method?
I'll just butt in, Sam. I don't know if you saw this question, but someone in the audience had a similar question. So it's good that you brought that up. Like, how do you deal with replication lag, reading your own writes, these kind of things? Yeah.
Okay, Simon, I'm gonna let you go first. Because
I'll go first, and we'll deal with this, and then I wanna flip over and ask you some questions.
Okay.
So replica lag. The way that Justine and I did it was that we just set a session in Memcache. Just like a key that says like, okay, every time you do a write, we set the key, right? So you can imagine like shop ID, and it's just like go to the writer, like : go to the writer. That's it. And then we would go to the writer for like 10 seconds to until replication lag had caught up. You have to be so careful, and you have to taint the objects that come back from the read replica to make sure you don't write them back. And then you have to have alerts in place when the replication lag is high. You have to throttle writes. So that's the overline. And then you have to do a lot of work to make sure you don't overwhelm. The biggest point of overwhelming the replication lag, other than large sales, would be background maintenance task, right? Someone who's like, hey, I need to update this column, whatever, right? Run it into user code and write it back. And so we wrote this thing. This was part of another project, actually. It was an idea implemented by one of my coworkers called Kier. And the idea was like, okay, every maintenance task has to just be like expresses an enumerator. And then every time you do like a batch of 1,000 or whatever, we just check the replication lag. And if the replication lag is too high, or the threats in InnoDB are too high, the two signals we were looking at, then we would just hold off and sleep, right, for a while. With that, we were able to control replication lag incredibly well, but you have to taint your objects, right, coming back from the read replica to make sure you don't write them back. And we even did this, like we had one MySQL that was running like across all the regions that were doing sort of like which shop is in what region and sort of the metadata layer. And even that we did cross database reads for a little while. And we actually added sleeps and stuff into the code and sampled it up before shipping it, just to make sure that the application was okay with that latency when going cross-continental. Production sleeps is like a great way to test these things before they go out. But that's mine. Is that yours too?
At GitHub, we dropped a cookie. And so if the next request
why a cookie instead of doing it server side?
I don't know why they chose to do that, but it worked incredibly well. And if it had that cookie, you would get pinned back to the master, and it sent most, because most was reads, right? With generally, to answer the question, we do things, and speaking, you were talking about those batch jobs, right? We do a similar approach for schema changes. We always manage the lag on the cluster so that we can always watch and slow them down and throttle them, and you can make them more aggressive and less aggressive. The thing is, it's technically eventually consistent, right? Like we have semi-synchronous replication, so when you do a write, it gets sent to another node, but not necessarily like fully committed. We know it's made it into the redo logs of the other node, bin log, sorry. So it's at least gone before we acknowledge the write. But if you start to hit replication delay and you start trying to read your own writes, it's like you're going to miss that data. And that is, I don't even want to call it downsides, like just a design pattern, right? Like these strongly consistent systems have, you referenced Spanner earlier, have massive downsides on latency. And so, yeah, you will get stale data, but you'll also know and be alerted that you're lagging your replicas, right? Like you just should avoid doing that. There's like way more signal for you to like avoid that happening. It just doesn't tend to happen that much if you keep your system kind of well managed and well utilized, basically. I wanted to ask you about your the Shopify, how you do multi-data center and multi-region.
We can go into that, and then we should talk about some of the database outages recently. I think we'll dovetail into that.
Yeah, okay, we can go there. We can go there. Not planets get outages.
How do we do multi-data center? I mean,
can I just set you up on that one, by the way, because sure. The big common thing everyone wants to go for is active, right? And my big message is that you just don't need it. No. But why don't you need it?
The biggest sites in the world don't have active. No.
Right. So let's hear from one of the biggest sites in the world.
So active means in something like GitHub or Shopify, whatever. It basically means that you're serving like production traffic out of multiple data centers. Has huge engineering costs. It's just the real reason that you have you have multiple data centers is really more to like insulate you from your own failures than those of the clouds. Like they're very, very reliable. And often if you have a region that's like really problematic from the hyperscalers, like it's often some backbone error and it's difficult to fail over, like we've had those too. So it doesn't insulate you against every kind of failure. The main reason why if you want active, it should be more on the read path. So Shopify does have active in terms of serving sites out of multiple sites, right? Like going from Australia to US East is just like, that's just going to suck and it's going to have low conversion. So Shopify does serve that out. But active passive is the design Shopify had. This was work mostly done pre-IPO because this is one of the things that like you want in your S1 that you can fail over between data centers. So that was the first tranche of it. And it was basically like, okay, we have like, this was on-prem, like we had all of our hardware sitting in Chicago. We spun up a region in Ashburn, Virginia. And then all of the hardware was just sitting in Ashburn doing nothing. And then we just had like a spreadsheet with like 20 points to execute the entire failover. And we did that once in a while, right? And then it made sense to the other data center. This is like the common thing. That was great. Shopify IPO'd with that. Like this methodology supports like hundreds and hundreds of billions in market cap, and you probably don't even need it. That's the first one. The second iteration, I worked a bunch on that. This was like it's like 2015 for Shopify, 2014. The next iteration of that was what we called pods. So Shopify started in 2013, went multi-data center in 2014, and then in 2015 we did what we call pods. A pods is basically just like a superset of a shard. It meant that every Shopify shard was not just sharded at the like database level, which was the biggest one, but also at the caching level. At like every level in the application, it could run independently from everything else. And this required a lot of work. But it meant that basically you could take like a shard and you could have a shard running in Ashburn and other shards running in Chicago.
This is just the data plane. Front ends and stuff is completely separate.
Exactly. Yeah. Okay. Well, no, this was the same. Actually, that was all the same. That was moving everything. So so we had all of that. Like, let's say there's like 128 of these pods, right? And so just like completely making them independent so they can fail over between data centers. We just had a little Slack bot that could do it, and it just executed it. It paused the requests. There was basically no downtime, especially not for reads. Paused writes for a few seconds, right? And Nginx Lua, again, Nginx Lua was like the go-to thing. We played all the caching and whatever infrastructure tricks. And then we basically just allowed it. So we had 64 shards running in Chicago, 64 in Ashburn. And then once in a while, we would we would move them around, bound the regions, things like that. That's what we had. That's presumably also what they do today, except the storefront is now separated out and can run in many more regions. Works great.
It's truly simpler. That sounds very complicated to someone who's never done it. It's even simpler than just there's solutions that market themselves as being very simple, right? Like the database will handle active and quorum across data centers. When that goes wrong, that is so much worse than this simple model of essentially having a primary region and a replica region. Even if you overlap those regions and have different primaries for different parts of the world, it's a shame the merchants of complexity have sold so hard on the simplicity of like these quorum-based databases or state layers.
I think for me, and this is like, to the people working on these databases, I think this argument doesn't resonate at all, but it probably resonates with you and other people. And this might be one of these things where maybe databases just advance one like SRE funeral at a time. I'm not sure. But the reason why these like consensus quorum-based databases like Spanner, why I find them like difficult is that I just don't understand them. Like I've spent my whole life on like working on databases, and I don't understand these things. I don't understand fully how the clocks work. I don't understand like I don't understand it well enough. And it's just like I like simplicity. I prioritize simplicity over everything, including performance. We just wrote a blog post about how we basically the queuing that does a lot of the indexing and stuff in the background is just a single JSON file on object storage, and it's just like simplicity over everything, understandability and simplicity over pretty much everything, including latency, if things can live with it. And that's just why I don't love those things. And I think probably if you've like grown up with these things, maybe you understand them, but I don't.
I don't think anyone understands them at 3 a.m, and that is the most important time to understand these things, right? Like this is a conversation we have with folks. You were talking about like replication delay, right? That's a significant, like eventual consistency is so much easier to reason around than like a distributed transaction failing, and why. And what can go into that, like, and what these clocks Simon's referring to is that to be able to like do a kind of cross shard, cross cluster transaction that validates against other nodes, you have to have, every node has to have an opinion on the exact moment in time so that all state can be analyzed at that exact period of time. And that itself is a incredibly difficult problem, which led Google to putting atomic clocks in their data centers, which to me is just crazy. Like, I mean, it's fun. I mean, if you're bored, it's fun to fuck around with, but like other people achieve the same result.
Sam, we should get some of the developers on who've worked on these databases and just have the debate live, because I think it would be so fascinating, right? Like, I would love to just like hear what's your retort to this, right? Is this like, are we like or do we sound like just like disheveled cavemen like to you? Like, what's the, like, I would love to hear, and especially someone who is on call for those systems, right? Because I mean, maybe we have some room to move here, but I think that's sort of where I stand. Speaking of databases, speaking of outages, speaking of reliability, you've like really taken to X over the past few weeks. There were some outages in database land. I think generally, Sam, there's a bit of like a unspoken rule that in SRE land, probably up until some threshold, we don't downtime shame. But it seemed like that reached the threshold for you, where you felt that it was. Yeah, can you talk to me about that?
Yeah, and there's like hug op stuff and all those types of things. Like, you shouldn't talk shit about outages and whatever. That has been the way. That has been the way for a very long time, and I've been a proponent of that, and then I went away from that. I don't know how I feel about it, other than my position on this now is that the way things are marketed, like we're in a very hypey cycle right now, like in the hypiest of hype, right? You're seeing this everywhere, and words barely mean anything anymore, right? Like, you go on Twitter, you can't just decipher what's real and what's not real. And there's a lot of marketing budget going behind convincing folks to use these kind of infrastructure platforms. We don't even have to say like it's database specific. It's just infrastructure that people want to put their business on and plan their business, right? And they talk about reliability and scale, where they like just don't have to. I think it gets to the point where all of my empathy swung towards the user base. And I also think this goes down to the volume of these things happening, which is like, it's a constant. Have you noted this now? Like, it's a constant for certain platforms to have constant availability issues, to the point where they don't even like update their status pages, right? Like, they just lie, because and the users report it constantly on Twitter. And I don't know, man, like, we spent a lot of time in our youth very stressed about uptime and working really hard to avoid downtime. And I feel like for financial gain, people are getting into domains where this is critically important and massively letting people down. And I've just kind of had enough of it, honestly, because like we don't spend our innovation points or tokens on frou fancy shit all day long, because so much of our roadmap, like 60% of our roadmap, is just eaten by reliability, availability. Every time an incident happens, massive amounts of remediation work just for tiny things, like stuff like declaring incidents before things even affect users, and then like what was going wrong. We have to compete with these companies. Like that's a fact. Like we have to compete with all of these ones out there selling databases. It feels like an unfair fight. And again, like I said, it's lame to like complain about fairness, because luckily people are realizing this now. But when folks throw all of their efforts into just hypey shit that gets nowhere, right, and doesn't spend any time on reliability, it's just the users that suffer. And like, what's the worst thing the user did? Believe the marketing pages of these companies? Like, you know what I mean? Like, it's just wrong. It just is wrong to me that they do it this way. Yeah, and I've like had enough, and I'm happy to call it out. And I would call out our failings too. But I just think the users, they just deserve better. They like truly deserve better, because the like we had charities reaching out to us that were like stuck, like they couldn't like move food to people. We just had people that said they, like someone wrote to me and said, I think we're doing a trial with our first ever 6-figure customer. I think we're going to lose the customer. And I just like, my heart goes out to the, like, it really just bothered me. And so, yeah, I exposed that it was going on, but most importantly, we got hundreds of people onto a new database platform very quickly where they gained reliability, and we gave away tons of credits for Planet Scale, which like comes out of our profits. It's not all like VC funded, right? Like it comes out of, but it meant that we saw like growth off the back of this, which was great. But I don't know. I just feel like in this world of AI and with the amount of software being built, building infrastructure and building reliable systems has to mean something. And it's an art that I don't want to die. And it's more and more important. And so, yeah, I just kind of, I had enough, because I think that kind of politeness of not calling out these issues doesn't help anyone in the long run. Like it doesn't help people get better. It doesn't help users make good decisions. It just, it's like, there's certain companies that if they have issues, you can be like, yeah, that must be an act of God or whatever, right? Like I'm really curious about what actually went wrong there, because it'll be interesting. There's others that if they get away with it, they'll still not spend any time on reliability. They'll just keep messing around with new things, and their users will get worse. So I think, as hype in the industry and seriousness is dialed up, and funding and all these things, I think the need to be serious about reliability has massively gone up. How do you feel about it?
I mean, we have different styles. I think that.
That's such a nice. I mean, we were. No, I'm just like, I laughed because I was just like, that's such a nice way of saying I'm not a loudmouth, but yeah, like you're not a loudmouth, but that's good. Carry on. You have different styles.
I think you want to, I think you really want, make sure that the companies that you depend on have values that you reside with. And I think that your values are very clear. It's reliability over almost everything, right? Mm-hmm. Like if you have, and you can tell in the comms of these companies how much they care about it, right? You can really tell how much they care. You can tell in the way that these companies interact with you. And I mean, we take reliability incredibly seriously.
Yeah.
I think like when we had our first customers on the platform, we had some incredibly long nights because we could just see on the graphs that if we didn't do these things, like we would go down. Yeah. And I think that experience and that empathy, I think you just need to have seen a lot of shit to truly have it. And so, I mean, I think you want to trust the values. I think you want to trust the people. I think you want to see these I think you want to see someone in the game for the right reasons. You and I are in the game of databases because we want to build incredible databases. We want our customers to move faster, better, and more reliably than anyone else. And if I don't know how you can truly learn that unless you've seen it, right?
Yeah.
Like I would not trust a database founder who has not spent a lot of time building on this. You and I, different as selling databases, is that we have operated and we've bought databases for a decade plus, maybe 2 decades, before we started selling them ourselves. And I think it gives us a unique perspective. You and I both have websites that are just like, this is what we sell, this is what it is, this is what it's good for, this is what it's not good for, this is what it costs, because we have just waded through so much bullshit being on the other side of this, where some new database comes up on Hacker News and I'm like, I'm on the website and I'm like, are they selling sneakers? Are they selling a database? Like, what's going on here? And to me, it's just like, engineering comms is just transferring the like mental model of something like as quickly as possible into someone else's head with as little interpretive overhead as possible. And there is just so much bullshit. And I think you and I just don't like, we've just been on this other side so much that we just can't deal with it. And that's what we spend a lot of time talking about internally when we publish blog posts, when we publish anything. It's just like, people don't have a lot of time. They care about the database that they run, but they care way more about their companies. And I think you're right that there probably some people will have bad heuristics for how to choose their database until they've lived through that pain, because they'll choose based on the hype, they'll choose based on the feature page and all of that. And I think both you and I don't want people to live through the pain that we've seen of choosing a bad vendor who doesn't care about these things and is not truly honest with their customers about what happened and what happens next. You call a code red internally when you get the threshold right? The threshold is probably somewhere around 50% of time on reliability-based work and 50% time on feature-based work. And some of that feature-based work is very much about reliability as well. And sometimes you get the threshold wrong for a little bit, right? As PMF hits you, new kinds of customers and cardinality of workloads, and then you call a code red to correct it.
Yes. And only one can bleed into the other, right? Reliability can subsume features, but features should not be able to do the other direction. How do you reconcile that? I love your website, by the way. Just now we've referenced it. It is a beautiful way of presenting the technical meat of a very technical product. We've gone for the similar. But how do you reconcile the fact that this might not work? Like, it might just be the hype that works. Like, I think we have to be okay with that. I'm not going to do it a different way. Like, I'm not interested in the other winning. Could it not work? Like, how do you reconcile that?
I had a similar question too, which just ties into what you were saying, Sam, which is like I think both of our companies' blogs, some companies like post a new blog every day, right? And it's just some like generic thing, right? Where both of us, seems like we don't post as much, but when we post something, we're trying to post something that's very useful to engineers that people find interesting. I know one of yours is trending on Hacker News right now about your queue, the JSON-based queue. So that also ties into it, right? Like how you market in terms of the writing you put out and the education you put out, which is interesting to me.
I mean, the biggest thing I've learned as an entrepreneur is you got to have the founder market fit, and which is what we just talked about. You've lived through the pain, you've seen all the bullshit, you've seen what worked, what didn't work. And it's just like, it took me a while to not get like persuaded by what other people who were like ostensibly extremely knowledgeable on a field. It's like, no, I have like the perfectly calibrated weights to execute what I think is right to build a big database company. And I think that it's taken many iterations and failures to decide, like, no, like the weights here, the weights that I have on how this has to be built, how it has to be positioned, are probably directionally correct, as long as I surround myself with people who generally agree with that and who could spend even more time on it and make even better decisions than I can. I've done things like building TurboPuffer that like I would have done differently if I had truly believed that. And now I'm just like, no, fuck it. Like, profitable company, like everything put together. Everyone who like joins the cap table, just like, look, it's this way. You have to trust it. And if not, like, we'll move to someone else who does. And I think you've also, I'm sure, in Planet Scale done things because other people were pressuring you to do them. And so it's just like, in some ways, it's just like, it just has felt very freeing, because now I'm like, no, this is just an expression of the values of this company. People get on board and they do it because they believe in the same thing. And then frankly, it's quite easy. It's like, no, I don't understand this blog post, so we're not going to publish it. I don't think it's valuable. I don't like this paragraph. I don't understand it, so we're not going to publish it yet. And then it becomes very easy.
Very easy. The lucky thing as well is that most cultures don't change. I just don't think if you don't get founded by people with an operations culture, you will ever, ever develop one. Have you ever seen an engineering culture 180 in that direction?
No. I think I've seen a lot of projects fail because a bunch of engineers came in who've only done engineers, and they have not been on call for systems, and they did not have the respect and humility of what it takes to operate systems at scale, and it just failed. I saw that so much at Shopify, where some company was like, we're gonna, rub some microservice on this, and then we're gonna own the whole thing and the operations of it. And these projects failed, and I was like kicking and screaming because I didn't think that this was gonna work out. And sometimes it was forced through, and I haven't seen it. Now I think some of those people probably come away from those projects and they're like, well, like now I've learned and I wouldn't do that again. But I think the operations and infrastructure, I think, is a very valuable skill set right now, as the cost per line of code is trending down so massively.
Yes. Having the people that run those services, and it's the culture around running those services, right? None of that is, we talked about this last time, none of it has made it into a model. It's like crucially important. The inverse is true as well, by the way. There's some people who are just generationally brilliant at building products, right? Like not necessarily with reliability or whatever, but like you get certain cultures. Google's a good example, which is like they've got tilted too far on certain reliability, and it means you can't get anything into, like, it means they develop very slowly and build very slowly, and like they develop as if everything is going to go from 0 to 2 billion users overnight, right? And then it means that like the creativity is gone. You need those fast iteration cycles to build good products, and then it's hard to like bake that into a culture after that's already established as well. So it's a double-edged sword. You need to like be able to do both like effectively and well. But yeah, it's gonna be interesting how this plays out. Like we just said, for 5 years, reliability and uptime is all that, like durability and all the others, like matter for databases. I hope that's true. I mean, AI has definitely kind of catalyzed that in certain areas and really shown it to be, but we'll see. Like we just have to see, right? Like I truly hope so.
We also, I mean, we talked about S3, how it's one of the best databases ever built, right? S3 doesn't do a lot. It's just like cheap, very scalable, and it's pretty slow, and it does a couple of things like, but it's like, when you know that, you look at the quota page, you look at the like napkin math of performance, and you look at the APIs, and then you think really hard about the constraints and trade-offs you can make in your system, probably design something pretty good. And so that's always how we thought about TurboPuffer too. There's like so many things that TurboPuffer doesn't do that our peers do. Like we don't even create the vector embeddings yet, because it's just like, I can't spread the team so thin to start running all of this yet. Like, of course, the time will come, but it's just like all been just prioritization of what we expose. It has to work really well. And there can be fewer things, and we will work hand in hand with our customers to use fewer things to do well. And we say that too on the website. It's like, we're first state retrieval tool. Like if you want to do the fancy ranking, you have to do some of that yourself. And like, I think that's good customer support as well. Like you offer a workaround, and then you say what will happen and what direction you're going. And that's the template we try to follow.
Do you think people perceive that as a weakness though? Because like in the last few weeks, I've been asked to do auth, compute, workers, all of this sort of stuff. And when you say no, they kind of look at you, and like the light kind of fades. They give you a look as if like you can't do it. And it's like, well, we could, but it's not truly what people are paying us for. Like you could get pulled in those. Like it's very hard, I think, to get it out there that this is a choice. This is not like just a skill issue or whatever. If maybe it's the opposite of a skill issue, right? Like it's actually just like discipline, which is really hard. Like how are they able to see that as some form of weakness? They're wrong, obviously, but like it could be.
I generally just say, look, the only advantage a startup has, and the only moat a startup has, is just focus and direction. And we have chosen that focus and direction in a very particular direction. We're not apologetic about it. We will tell you where we're going. We'll tell you where we are. We'll tell you what works and what doesn't work, what's not in the product. We'll tell you if you go to TurboPuffer, there's like pages of what the limitations are and what you can expect from them. Because I want people to just sit there and be able to design with those constraints in mind. And if that's not what you want, we lose customers to it all the time. And this is what, again, the bliss of the company being the most authentic expression of the culture of the company is just like, it's okay if we say no to a bunch of these things. And we have lost customers because we couldn't do some things that were very tempting and that was coming 3 months down the line. And that's okay. And some of those customers are coming back as the features are released.
Yeah. It also helps that you've got some of the best AI companies ever. Logos, anything you say underneath that works, right? Like it's also builds, right? You build this authority, they trust it, they learn it. Like people will know it goes around. It's beautiful.
But you don't, I mean, there's lots of logos underneath the iceberg, right? That's exposed that you just have to build a lot of trust before they want to associate their brand with you. I don't think people understand how difficult it is to get these logos on the website. It's not like they just sign up. Like some people do that. Like they're just like, they put like a bunch of banks on the website because inside the banks, it's like so hard to even figure out who has the permission. So they don't even know if they've given the logo right or not, but they almost certainly haven't. If it's a startup, I can tell you that. But it's like, we only put logos on the website if they're actually using it. It's in prod and like everyone's happy with it. And like that can take a long time. Like, from first request until we had the Anthropic logo on the website took more than a year, right? The Atlassian logo took longer than that. The Notion logo, like from the first time I talked to Notion, also took a year. Like these people do not see that. And I spend a lot of time on that and making sure that everyone is happy with the way that these companies are presented. I'm also sensitive to that, right? I don't want people to just like print our logo like next to something that we don't that we won't want to stand for.
Logo abuse is crazy, actually. In fact, one of the ones that had Downtime has the logo of a company I know very well, and I pinged that company. I was like, "Are you really using that?" And they're like, "Absolutely not. Some developer must have signed up." That's crazy, actually.
We need an independent body that like goes to these websites and pings the logos and it's like, hey, do you have the right? Like, just like there should be a little bit of sensibility in the system. But overall, I think honesty and transparency works, right? It's like the same in friendships and everything. In the long run, it will win. And people know. People are smart. They'll see through the bullshit.
Yep. We have a very large AAA games company as a customer, and I said, "Can we use your logo on the website?" They said, "You don't want that," and I was like, "I really do want that. I really want that more than anything, actually." And they were like, "No, you'll get death threats." I was like, "What if we have an outage?" They're like, "No, just you'll get them anyway." I was like, "What do you mean?" And they were like, "Yeah, I mean, if we make decisions about the game that people don't like, they just go after our vendors." I was like, "Oh Jesus!" And they reminded me of the game. Do you remember Gamergate? Like at GitHub, that was crazy. You don't know? Are you aware of this whole thing that happened around GitHub and Game?
No.
Okay.
No.
So
what was this?
Gamergate happened, and then someone did this satirical language that was just like sexist shit, like C++ derivative language, right? Super sexist, ridiculous, and we banned it obviously because it was just stupid. And then they started giving death threats to our employees and taking photos of the office and sending them. And eventually, I think someone wrote Gamergate on a mirror inside our office after coming to some event or something. They are, like it was like, so we don't have that logo on our website because I was like, I don't want that. And then we're also talking to another games company right now that has a very famous sports game, and they're like, if you have an outage, we get like, if we have issues, people post like pictures on social media of them throwing their controllers through their TVs. I was like, oh god. Yeah, that's a different.
So you have the rights, but you've chosen to not.
We don't have the explicit approval. If I'd kept pushing, I think we could. They were like, "Well, we can talk about it if you want. It's not like that big of an issue." But I was like, "Okay, we'll just maybe leave it there for a while and see how they feel." I should give it another go. I don't care about death threats. Maybe I'll get a Planet Scale swag bullet food fest or something. I'll be fine. But yeah, I mean, it's just wild. These things that like go on. Really nuts, honestly. Really crazy. Yeah, I guess I suppose you would have had a bit of that political angle with Shopify, but GitHub seemed to get swung into that all the time. It got used, and obviously, like, many ways to host content on GitHub that, you know, could be a problem, or, you know, that would piss off nation states and things like that. That's another really fun side of building something significant, right? Like you get to see this whole other world of like the crazy things that like go on and go wrong, and it's wild. It's nice to have that all in the part. We should talk about the China thing one day, because that's another whole crazy story. Which I may not have told you that full thing previously. That'd have to be for another stream. That's a long story. But yeah, we end up in these crazy situations always, and gamers get really mad if you make decisions badly or let their services down.
Wild. We should probably start wrapping up. Maybe Ben has a couple more questions.
Yes, one just came in, so maybe we'll just end with this. We'll keep it nice, a nice little softball for you. Is Redis HA something you will do? Would be a game changer indeed. I assume that's more for Sam, but I don't know. Maybe Turbo Puffer wants to do hosted Redis.
Is Redis HA even possible? that was a joke. I don't know. I doubt it. I doubt it'd be Redis if we did it anyway. I don't know if there's licensing that makes that. We're always thinking about these things. Look, if anyone can email me and try and convince me. The current most requested, Simon, could you get a guess what the most requested data store that we run, what people want us to run is? By a wide margin.
It's not Redis and it's not Memcache. Then this is a wide margin?
Wide margin.
Elasticsearch. Elasticsearch.
Nope. I have been asked that actually a few times. ClickHouse.
Oh, interesting.
Yes, we do get that a lot, actually. Yeah.
Yeah, constantly. In fact, in person twice this week alone. In person. It's wild, right? Like everyone wants us to run ClickHouse. I would say I don't know why. It goes down to that same thing about we did Postgres. I have to just the bar for whether we'll do Redis, do anything, and maybe it would be a game changer if it's next to your database. I agree. Would be, can we have an impact? Like I have to convince myself that PlantScale is somehow uniquely the right people to do that. We easily convinced ourselves of that with Postgres. I haven't done the work to convince myself of anything else yet.
Let me weigh in on this one too. So I would try really hard to design your system to not rely on HA for Redis, and just use it as much as possible, of just having a big farm of Redises that you consistently hash to as much as you possibly can. The one exception to that might be if you're using Redis as a queue or something like that. But we switched away from that. We had some nasty outages because we just had a Redis called Redis, and we didn't really know what was in it. There was just like 200 gigabytes of RAM, and at some point it got wiped but accidentally, and it was a nightmare because people had just been tossing things into it for 5 years, and it hadn't had any significant outages. It's a phenomenal piece of software. And I think it's like a great tool in the toolbox, like Nginx Lua and other things, where you can do a lot of incredible things with it. It's very easy to shoot yourself in the foot. And I think bringing any persistent state other than queues into it, not something I would do.
Yes. We had a 4-hour GitHub outage where a good 2 hours of that was waiting for a single threaded Redis process to load 80 gig of data off of a disk. Like we just needed, like, do you remember the days where unless the full data set was there paged into memory, like Redis wouldn't serve a single query? The whole site needed that Redis instance to be up, and we'd lost a ton of. Hello, CEO of the CEO of Redis is here. Hello. We are big fans. Like you said, we've great software.
We're big fans of, like, just to be clear, we're big fans of Redis. I think it's a phenomenal piece of software. And I use it. We've used it all the time. We just don't use it at Turbo Puffer because we don't have any databases as dependencies. It's just like I could talk about good things of MySQL and bad things about MySQL. I could talk good things about Postgres and bad things about Postgres. Everything has trade-offs. And maybe as with these distributed databases, my understanding might be fixed in 2018. I don't know. But trying to do Redis HA, last time I had to do it, was not something that I wanted to do. I would still run, and I've run thousands and thousands of Redis machines and loved it, but used in a very particular way. Yeah.
I'm sure that's the advice from Redis too, which is like, stop doing crazy things. Like at GitHub, we found a new way to abuse Redis every time, like build queues on it famously.
Yeah, like what's the best queue? I just Redis. Use Redis for your queues. We have to use a single JSON file because we can't take other dependencies, but it's not as good as Redis.
Nope.
Well, maybe we need to get Rowan on sometime. I'll message you, Rowan. Fun.
Yeah, I think that would be fun.
Cool. Well, thanks, guys. We will wrap it up here. Thanks, Sam. Thanks, Simon. Good chat. And for everyone listening, we'll probably do another one of these in 2 weeks. So stay tuned. We'll have some guests on. It'll be a lot of fun. So take care, everybody. See you later.
Thanks all.